Good day everyone, especially to our instructor, Mamel Juan B. Dizon. For today's video, I'm going to discuss the performance task in Lesson 6 by answering the following question. Question number 1. Based on the discussion, what is the difference between light-dependent and light-independent reactions? My answer is, in the light-dependent reactions, energy from the sunlight is absorbed by chlorophyll and that energy is converted into stored chemical energy. In the light-independent reactions, the chemical energy harvested during the light-dependent reactions drives the assembly of sugar molecules from carbon dioxide. Therefore, although the light-independent reaction do not use light as a reactant, they require the products of the light-dependent reactions to function in addition. However, several enzymes of the light-independent reactions are activated by the light. The light-dependent reactions utilize certain molecules to temporarily store the energy. These are referred to as energy carriers. The energy carriers is that move energy from light-dependent reactions to light-independent reactions can be thought of as full because they are rich in energy. After the energy is released, the empty energy carriers return to the light-dependent reactions to obtain more energy. Calvin's cycle used the chemical energy to produce from stage 1 to build G3P to the precursor to glucose and other molecules, also known as light-independent reactions and dark reactions. Number 2. How are photons absorbed and utilized in the first stage of photosynthesis? When a plant is exposed to light, photons of appropriate wavelength will strike and be absorbed by the pigment protein complex to arrayed on the thylakoid membranes. When this happens, the energy of the photon is transferred to the pigment molecules, thus causing the pigment to go into electronically excited state. In the first part of photosynthesis, the light-dependent reaction, pigment molecules absorb energy from sunlight. A photon strikes photosystem to initiate photosynthesis. Energy travels through the electrons transports chain, which pumps hydrogen ions into the thylakoid space. This forms an electrochemical gradient. Number 3. Summarize the process of light reaction in Calvin's cycle. So to summarize photosynthesis, it is occurs in two phases. The light reactions, light and the water go in and oxygen comes out, as well as the ATP and NADPH that are used in the Calvin cycle, where carbon dioxide comes in and organic products like sugars come out. In the light-independent reactions or Calvin cycle, the energized electrons from the light-dependent reactions to provide the energy to form carbohydrates from carbon dioxide. Molecules, after the energy is transferred, the energy carrier molecules return to the light-dependent reactions to obtain more energized electrons. In this way, photosynthesis is almost like the reverse of cellular respiration. Both process involves a series of redox reactions wherein the electrons just flow in opposite directions. In the photosynthesis, sugar is built while in cellular respiration. Sugar is degraded, broken down. Number 4. What are all the byproducts of light-dependent to the light-independent reactions? The products of the light-dependent reactions is ATP and NADPH have a lifespan in the range of millions of seconds, whereas the products of the light-independent reactions, carbohydrates, and other forms of reduced carbon can survive for hundreds of millions of years. The main products of dependent reactions are glucose, ATP, and O2. Photosynthesis takes place in two stages: the light-dependent reactions and the Calvin cycle. In the light-dependent reactions, which take place at the thylakoid membrane, chlorophyll absorbs energy from sunlight and then converts it into a chemical energy with the use of water. The light-dependent reactions release oxygen as a byproduct as water is broken apart. In the Calvin cycle, which takes place in the stroma, where is the chemical energy derived from the light-dependent reactions is to drive both the capture of carbon dioxide molecules and the subsequent assembly of sugar molecules. The light-dependent reactions, or Calvin cycle, it is used to store chemical energy from the light-dependent reactions to fix CO2 and create a product that can be converted into glucose. The ultimate goal of the light-independent reactions, or Calvin cycle, is to assemble to a molecule of a glucose. The Calvin cycle, it is occurs in the stroma of the chloroplast. The inputs into the Calvin cycles are NADPH, ATP, and CO2. The products of the Calvin cycle are NADP plus ADPH and sugar. The carbon of a sugar comes from CO2. So, once again, this is Irene Babor Mailan. Stay safe, everyone, and God bless us all. Thank you.